Right, so welcome to we're going to do the question 2s and 3s from 2022 and 2021, it's paper 2 chemistry. So let's just dive right in, right? So here's question 2 for 2022. Now we have to study this table of the 6 organic compounds, and the first question is write down a letter that represents 2 organic compounds that are isomers of each other, meaning they're the same molecular mass, but something else is different. So if we just take a look here, these two will have the exact same molecular mass because they have the exact same amount of carbons, hydrogens, oxygens, whatever. The exact same amount. Therefore, they will be isomers. C and D is the answer there. C and D. What type of isomer chain functional position is identified in 2.1.1? So we've identified these two. So there's not well, there is technically, but what's happening here is that there is a functional group change, meaning C is a aldehyde and D is a ketone. So you have a functional group or homologous series change, so therefore it will be functional in this case. Okay, B asks, what is the general formula for the homologous series to which B belongs? So that is an alkyne, and just from studying you should know that it's CnH2n minus 2. An alkane is a plus 2, alkene is just 0, minus 0 or plus 0, and the alkyne is 2n minus 2. Name the functional group for F. Look at F, there it is, it's an alcohol, but careful, don't write alcohol. The functional group is this OH part here, and that thing is called a hydroxyl. It's a hydroxyl group, so just watch out for that, but dihydroxyl group, OH. Now write down the IUPAC name. What is the name of A? Take a look at A. So I'll actually just redraw this so that it makes sense to me. But or we can just we're just gonna name it. So it's actually no, it's fine. We just follow the longest chain. I think that's the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. 4. That's 5. Oof, they're gonna trick you with this one. So that's 6. So that's a hex. And let's just draw that in so we don't screw it up. Now, do we start from 1 over here or 1 there? We're going to start where we have the lowest sum of the substituents, so it'll be like this. So we have a hex, and it's going to be a hexane, but we have a dimethyl over here by position 3 and a bromo by position 4, but bromo comes first, so it'll be a 4-bromo, 3,3 dimethylhexane, and that's correct. So the next one is the name of B. So let's do B quick. Well, when you work on the alkane, you have to include the alkyne, you have to include the triple bond in your naming, and you have to start from the side closest to it. So that'll have to be a 1, 2, 3, 4, 4. So our substituents, therefore, are this guy. There we go. So let's see. We have then alkyne, but it'll be at position 2. 2 alkyne, or we can go alk 2-ine. And the alk or the chain is going to be a 1, 2, 3, 4, 5. So it'll be a pent 2-ine, and we have a dimethyl group, both at the same point of 4,4 dimethyl pent 2-ine. Right. That's that. Right, C. That's a nice one. So we're just going to straight up go like this, and that is an aldehyde, and that will end with the L, and it's a 4-chain, so it's a butanol. And we don't care about positioning because it's a terminating functional group will be terminating, so it will always be position 1, so we don't write 1 butanol or anything, we just write butanol. Right, jumping down to 2.3, it says compound F reacts with a carboxylic acid to form ester. So compound F reacts, that's an alcohol, reacts with a carboxylic acid, so it's going to form an ester, right? And in the presence of a strong acid, which is that concentrated hydrochloric acid, and you have to add heat as well, it's a catalyst. The strong acid is a catalyst. So what reaction takes place? That is your esterification, because it's a reaction between an alcohol and a carboxylic acid. Now here comes the cool part. It says compound S, which is your ester, has an empirical formula of C3H6O and a molecular mass of 116 grams per mole. Write down the molecular formula of the carboxylic acid. Quite a tough question, it's a level 4 question this, but let's just take a look. Okay, so the plan is to find the molecular mass of this, or the mass value of this empirical formula, which will be 58, and then we take the molecular mass as the mass of the molecule, and I hope I spoke correctly there, so but let me just say that again. Now we have to work out the mass value of this empirical formula, and we're going to take this for the ester. Can you write this down? And if we work that out, we get 58. And it's grade 10 work, but now we want to find out we're trying to find out the molecular formula of this ester. Not yet the carboxylic acid. We're going to have to draw a picture and try and find out what it actually is. So don't just, if you must read that correctly, that's not going to be the ester. It's going to, we'll get to that just now. So the mass is this, but they're telling us that the empirical formula, or the molecular mass of the ester is 116. So remember in grade 10, we just divided 116 by 58, and then we actually get the factor, which will be 2, to find the molecular formula of the ester, S. So this is the empirical formula. So the molecular formula will be C3H6O1, and I'm just gonna circle that. So times 2 times 2 times 2, and we get that to be C6H12O2. But that is for the ester S. The cool part here, now we know it's a 6-carbon chain, but like how many carbons left and how many carbons right? So remember an ester as a functional group looks like this. But how many carbons will be on the right and how many on the left? So what we do is we go back to the question and we see that they're saying this alcohol reacted with it. How many carbons does it have? 1, 2, 3, 4. And it's the alcohol portion which will be on the left of that, oxygen. 4 carbons to the left. 1, 2, 3, 4. Right? And okay, so you have 4 carbons on the left, but how many carbons are there in this ester? 6. So we have 2 remaining, which will be on this side. Just change the color there a bit. So what is this thing? This is now the carboxylic acid portion of the ester. So if you rewrite this, that is the carboxylic acid, and that thing's molecular formula is C3O2. Ooh, almost forgot the other H's. Almost said H1. that will be 6H6. I just realized a mistake. Yeah, looking at this, there's 2 carbons to the right, but I mean it's actually included there. Sorry about that, that's my bad. So this actually falls out and it looks like that. There we go, that's better. So we get C2O2H4, or actually it's C2H4O2. Sorry, it's better this way. There we go, and that's your answer. I hope that made sense. Sorry about the error. All right, going to question 3, same paper, 2022. Let's look at question 3. And we have a melting point of organic compounds given the table below. Now we're going to deal with those intermolecular forces, right? Chain lengths or mass of the compound. Let's take a look. So we got a propanone, butanone, a pentatoone, and a 3-methylbutanone. So everything's going to be ketones. And it seems like the melting point, the boiling points increase this way, but now this is an exception, so it's probably got like a group attached to it or something. Let's take a look. So to which homogeneous series do the above group compounds belong? That is your ketones. And then they say the melting points of ABC are compared. Write down the controlled variable for this comparison. What is being kept the same? It is the homogeneous series, right? Or it's ketones. They're all ketones, so it'll be the homogeneous series or the functional groups. We can say functional groups. The melting points of C and D are compared. Okay, so pentan 2. I'll probably draw this out to make a lot more sense. I'll draw them out quick. All right, so I'll draw them here. This is the pentan 2-on, and this is the other one, the 3-methylbutanone, and it doesn't have a butan 2 or 3-on because no matter where you put that carbonyl group, it will still end up in the same spot. So that's why we don't indicate its position. Now, why is the boiling point of pentan 2-on higher? Remember, usually look at a number line, but it's higher than 3-methylbutanone. Why is it higher? And we go according to this reasoning here. Pentan, it's got to do the chain length. 2-on has a longer C chain. And therefore, it will have more surface area for the London forces to interact or act between the molecules. This will result in stronger intermolecular forces which will result in a higher boiling point, or you can say pentan 2-on has a higher boiling point than butanone, 3-methylbutanone. Straightforward, eh? Easy peasy. Just know your rank B. Okay, looking at 3.2 now. It shows us vapor pressure of straight chain primary alcohols at 300 Kelvin. It's like 20 something degrees. Just remember, Kelvin is equal to degrees Celsius plus 273. So probably about Oh, what's the maths here? What's that, 27 degrees? Okay, anyway. Now you have an alcohol, and the only thing happening on this side is that the chain is becoming longer. You're keeping the functional group the same. And we have a vapor pressure decrease as you increase in the chain length. Now we know that your intermolecular forces, the strength of the intermolecular forces is inversely proportional to that vapor pressure. Or you can say, yeah. Okay, so as we go down that table by the alcohols, the chain length increases. Remember, it's like the previous ones, RAINP, it's the same thing. Let's see what the questions are. Define the term vapor pressure. I'll just study that. Write down a suitable conclusion for this investigation. As I was saying just now, as the chain length increases of alcohols increases, the vapor pressure, will decrease. An increase in chain length of the alcohol will result in a lower vapor pressure, or the higher the chain length, the lower the vapor pressure. All right, straightforward one there. Write down the IUPAC name of the alcohol with the highest boiling point. Now remember that the same as this, the strength of the intermolecular forces is inversely proportional to the vapor pressure. Same with the BP. So your boiling point will be inversely proportional to vapor pressure. So where's the vapor pressure the lowest? That is the guy with the highest boiling point. So this will have the highest boiling point compared to the other values. So we will have to name this thing. So that's a 6-carbon chain alcohol. So let's draw it quick. I'll draw it quick. Right, I drew it there. There's a 6-carbon chain with that OH at the end there. The hydroxyl group. So this thing will be called it's hex and 1-ol. Hexane 1-ol. Alright, now 3.2.4 asks if the experiments are repeated at 320 Kelvin, will the vapor pressure of each compound increase, decrease, or remain the same? So an increase in temperature will result in an increase in the vapor pressure. So the vapor pressure will increase. It's directly proportional there. Okay. Right, looking now at question 2 for paper 2 2021. Letters A to H represent the 8 organic compounds, A, B, C, D, F, G, H. Alright, so a whole bunch of different ones there. Define the term unsaturated compound. That's a alkene or alkyne. There's a double bond or triple bond in there somewhere. Saturated would be only single bonds, but y'all just know that definition officially, the official one. Write down the letter that represents an unsaturated compound. So we're looking for a double bond somewhere. So, when I mean double bond, I don't mean this. I don't mean carbonyl. It's between 2 carbons. So that one, that'll suffice. B. B is the answer. Okay, 2.2.2. Name the functional group of compound C. The functional group. So, risky just to guess as I draw it out. So let's take a look. Oh. I almost got tricked here. The functional group, I was going to name the homologous series, or the homologous group it belongs to, but they want the functional group. So that's almost got me a CA. So it's CH3. Okay, there it is there. And the functional group is this thing. That thing is called a carbonyl. So watch out for that. Okay, so they want us to find the letter that represents a chain isomer of compound C. Now, this thing, by the way, this is C. It is a 5. It is a pentane 2-one. It's a pentane 2-one. And we need to find something else that's a chain isomer of it. So it's got the exact same amount of carbons and oxygens and hydrogens, but there is a deviation in the chain. So it can't be butanol, because now you're changing the functional group, or you're changing the position of it. So you're changing the actual functional group. But in the whole homogeneous series, you're actually looking for something like, I think this might work, butan 2-one, so meth F prop but 4, C, 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 position 2. And at the third position, there's carbon 3, you have a CH3 up here. So there's a scafing, a moving of the chain. Just this CH3 will now, it doesn't go there, it goes to this one and then forms a different type of branch that branches out, where this is a straight chain, now it branches out, but it's the exact same formula, it's the exact same functional group, it's the exact same homogeneous series, it's just you got to change in the chain. So that'll be F. Okay, so let's name G. We'll be over here, there's G. So let's name it quick. So we have how many carbons there? We have 1, 2, 3, 4, 5, 6. I think they want to see which way you're going to name it from. So if we go left to right, we have 2, 3, 2, 3 plus 5. So that'll be 10. If we go from left to right, we have a 2, 4, 5, and we have 11. So you have to name left to right. So that will be the trick there. Alright, so we have a 1, 2, 3, 4, 6. So we have a hexane. And we have chlorines and methyl. Chlorine comes first, so we're going to methyl in its position 3. Oops. And the chlorines are at 2 and 4, so it's 2, 4, and it's a dichloro 3-methane. I just realized that 4 shouldn't be there, I can't count. That's 4 and that's 5, so it's 2, 5 dichloromethane, 3-methyl hexane. Alright, and then they'll ask for the general formula for E, which is C2H4, CC, and you only have 4 hydrogens, so it can't be alkane. What about double bond? No, 4 hydrogens, yeah, that's alkene, right? If it was a triple bond like this, you just have 2 hydrogens, so this would be C2H2. The double bond, you have C2H4, and if it was a single bond, you'll have 6 hydrogens on that, so it'll be C2H6. So it has to be this, and that's an alkene, and the formula for that would be CnH2n. This is plus 0 minus 0. Remember, alkanes are H2n plus 2, alkenes are H2n, and alkynes are H2n minus 2. Okay. Right, the next question is, what is a functional isomer? Now, that's just when the functional group, they have the same molecular mass, but then they have different functional groups. So, for instance, you have if you look in the beginning of your book, there you have the carboxylic acids and the esters are isomers of each other, or functional isomers. They have the same molecular formula, but different functional groups. But what I wanted to say was, I can't remember what I wanted to say. Let's just go on. So isomers, I said they have the same molecular mass. It's actually better to say they have the exact same molecular formula, not molecular mass. For compound A, write down the homogeneous series to which it belongs. Alright, so let's take a look. A, homogeneous series, that's easy. That's a COOH, so that will be our carboxylic acid. That will be ethanoic acid, ethanoic acid, oops. Alright, for compound O, draw the structural formula for its functional isomer. So that's a lovely question. The functional isomer, remember it's the same molecular formula, but the functional isomer of a carboxylic acid is an ester. So a carb acid and an ester, they are functional isomers of each other, and the aldehydes and ketones also, because they're the same molecular formulas but differing molecular masses. You can look at page 4 and 5 for that. They have the same molecular formulas but different functional groups. Alright, so let's see. Let's draw an ester that has the same amount of everything. Here we are. So we need to like move some things around so that we still have, we have an ester, so we have a carb on this side. So what am I doing? I have O, but it can't be a H here, it has to be a carbon. And whatever on the left here, but now we already used this carbon, we only have 2 carbons. So if we end up with a H like this, I mean, there we go, that works. So that is a methyl methanoate. Sorry, let's do that again. Methyl methanoate. Easy. All right, next. I think they're trying to trick you because of that hydrogen there. Okay, the next one says compound D undergoes dehydration. Oh, so we don't have to worry about this, but let me just check quick. Yeah, I thought it might have been this. Okay, so dehydration reaction, it's not really, yeah, this is a esterification type of thing, but backwards. So let's just take a look at that. So compound D undergoes a dehydration reaction. Write down the IUPAC name of compound D. So they're trying to see if you remember a carboxylic acid and a ester both have the same molecular formula. So there should be a 2 carbon ester. Sorry, my bad, it's not an ester. It will be an alcohol. So the alcohol gets dehydrated. So now it's stuff we kind of haven't dealt with yet, but let's just look at it anyway. So the IUPAC name of this thing will be a 2.5.1. It will be ethanol, and we don't have to give position because no matter where you put that hydroxyl group, it will just be ethanol. Ethanol. The letter that represents the product of this reaction. So ethanol will react with a carboxylic acid and form a product. So yeah, listen, this section's not supposed to be in. Yeah, let's just leave it. Okay, I think this is, yeah, it's not a, I spoke a lot of nonsense now. This is not a esterification reaction. Apologies about that. I just realized as I was going on, dehydration, we haven't dealt with this, no, just leave it alone. Alright. Don't know why I thought that was the esterification backwards, don't know why. Alright. Anyway, let's carry on to the next question. It's kind of late in the evening, I guess. So, let's wake up a bit. Oh, I can't make coffee because there's no running water at the school. You know, that's ridiculous, eh? No running water. So, and all the kettles are empty, and so is the urn. I don't understand. Anyway, so maybe I'll see if I can make a cup quick so I can wake up. On second thought, I'm not going to make that coffee because just now the battery dies because it does seem like it's a bit flat now. So, okay. Question 3. Start on a new page. Still 2021 chemistry. Start on a new page. We have melting points, boiling points for straight chain alkanes shown below. Pentane, hexane, heptane, octane. So as you increase the chain length, you will do a few things, and we have the boiling point increases as your chain length increases. Sorry, what did I say? The melting point, and the boiling point also increases. All right. So to find the melting point, I just study that. 3.2, write down the general conclusion can be made about the melting points of straight and alkanes. The longer the chain, the higher the melting point. Name the van der Waals forces between molecules of octane. Remember, alkanes only have London forces or induced double forces. They do not have double, and they do not have hydrogen bonding. They only have London. So longer the chain, maybe they speak about that just now. I don't want to. Okay, choose from gas, liquid, or right. Where we now? 3.4. Write down. This is London. 3.4, write down the predominant phase of the following alkanes at negative 100 degrees Celsius. So you just draw a number line. There's my negative 100, there's my 0. So is pentane a liquid, solid, or gas at a negative 100? So this is my temperature. To the right will be, if I am to the left, I have a, right, okay, let's just look at this carefully. So I draw a number line. This is the best way to do this. This is where we're at, negative 100 degrees. Its melting point is less than that negative 100, and its boiling point is more. So the temperature is between the melting and boiling point. Therefore, it is a liquid because it is between. This is grade 10 work. It's pretty awesome. And what about octane? Octane, it says, I'll do it now. Octane is, we at 100 degrees. Let me just put that back. We have a negative 100 degrees. Octane's melting point is at, why am I doing that? Is at negative 57. And its boiling point way up here, 125. So the temperature we're looking at is negative 100. It is left of the melting and boiling point. So octane is therefore a solid. Let me just give you guys a little summary here. Right, here's a summary. Your solid, if it's a solid, if the temperature is less than the melting point, makes sense, right? Think about just ice. Like if you have the temperature of the freezer less than the melting point of water, then you'll have ice, right? Liquid is where the temperature lies between the melting and boiling point. So if you take, looking at water, you take the temperature to 20 degrees, your water is a liquid because it's less than the boiling point of 100, but it's more than the melting point. And a gas is when the temperature is higher, greater than the boiling point. And for water, that would be 100 degrees Celsius. So if you have the temperature of 120, you'll have water as a gas. So I think it's good to imagine water when you draw this number line, so you can just like sort of reason how it works. All right. Hexane is now compared to 2,2-dimethylbutane. Hexane and 2,2-dimethylbutane. I will probably have to draw this out. Right, drew them out. Here's my hexane, and here's my 2,2-dimethylbutane. Alright, so is the molecular mass of hexane greater than, less than, or equal to? If you count the carbons, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and if you count the hydrogens, you'll also get the same. So their molecular masses are equal. If you just count them. So basically, the reason being they have the same molecular formula. So they'll both of them will be C6, H2n plus 2. So it's 14, eh? 1, 2, 3, 4, 5, 6, 12, 14, yes. So C6 and H14. Alright, then which one will have the higher boiling point? Is the boiling point of 2,2-dimethylbutane higher than, lower than, or equal to? It will be less than. It's got to do with chain length. So 3.5.2. This thing's boiling point is less than the hexane. Hexane's got a longer chain length. Remember, it's got to do with those London forces. So the explanation then is that if we're looking at the hexane, it has longer chain length, and therefore there is more positions or contact points for the London forces to interact between the hexane molecules. That's interact. And then, because they have more positions to interact, you'll have the higher intermolecular forces for the hexane, which will result in a higher, boiling point. Yeah, boiling point. Don't write melting point, a higher boiling point. Just it'd be nice just include there than 2,2-dimethylbutane. Okay, so 3.5.2, maybe start here with hexane has a longer chain length. Therefore this, therefore that, and boom, yeah, full marks. Actually, not full marks because I forgot to put in the, if you have high intermolecular forces, result in more energy required to overcome those intermolecular forces. Wow, can't believe I forgot that part of the RAINP. So we have to include that. And then we get a hexane will have a higher boiling point than 2,2-dimethyl butane. And that's it. Hope this helps for your exam. And yeah, start them.